Good morning, everybody. This is a video to talk about polyatomic naming. For the most part, guys, what you'll notice is that polyatomic naming involves the use of polyatomic ions that replace either the cation or the anion in ionic naming. Generally speaking, it's pretty much the same as ionic naming. You'll still list the first ion that is there that is listed. You still list the second ion that is there. If that ion is not is a single element ion, you're still going to change the ending to "ide" or to IDE. If you replace either your cation, the first element, or your anion with your second element with a polyatomic ion, that's when you need to start. Well, honestly, it's very simple. You just write down what the name is of that polyatomic ion. You don't have to change anything about a polyatomic ion. This on the screen is actually a couple examples of polyatomic ions. These are the ones you're going to see in class. Next, note that these are some examples of polyatomic naming. Really, polyatomic naming is just a special kind of ionic naming. This is where you have any compound that has more than just two elements. Note, like I did say a minute ago, the polyatomic name has never changed, regardless of if it's the first ion or the second ion. If we started changing polyatomic names, we'd stop being able to recognize them as polyatomic. So, look at these examples down below. We've got NaNO3, which as a name, the first ion is sodium, the second ion is nitrate. The overall name then would be sodium nitrate. Note that even though nitrate, the polyatomic, came second, you made no change to the name of the polyatomic. Going back, you can find nitrate somewhere, right here, sorry, which is an NO3 -1 charge. Note that it is a list, and it's exactly like it is on our ion list. Whew. Next, we got NH4F. The first part of this compound is our first ion, and that's ammonium. Note, the easy way to find out if, hey, is my polyatomic ion the first ion or the second ion, just check out what your first element in the compound is. If it's a metal, then your first ion is that metal. If it's a non-metal, this means that your first ion is going to be the polyatomic ion, and you're going to need to find out what that is. Generally speaking, that's going to mean it's nitrogen and hydrogen, specifically nitrogen or NH4, which is, of course, as you can see on the screen, ammonium. So we got NH4F, ammonium is NH4, F, because it comes second, is fluoride. Note, changing fluorine to fluoride because it's coming second. Put the two names together, you get ammonium fluoride. The final example is NH4NO3. Here you've got ammonium. And then the second part, everything that comes after the NH4NO3, that tells us that it's another polyatomic because there's more than one element. And then we find out what that ion is. It's nitrate. Put the two together. Ammonium nitrate is the name of this compound. Multiples of polyatomic ions. So whenever you need more than one polyatomic, you are still able to do the crisscross method, of course, to identify how many of each ion you need. Like I said, polyatomics really just like an ionic compound. We even treat those polyatomic ions like one thing. But the one difference that we see is that, well, when you need more than one of them, if you just put that number next to your polyatomic, it's going to look like it just needs more of that last element in the polyatomic, not the whole ion itself. To make sure that we can see that you need more of the entire ion in completion, we make sure we put parentheses around the polyatomic ion. That means any subscripts for any of the elements that are in it, and we put how many we need of that ion on the outside of the parentheses. There's an example down below that you can see, and that's it. Note, you do not have to have parentheses if there's a single ion If you just need one of them, just like normal, we drop the one because it's not required, and we do not have to put parentheses. Parentheses are only for when you need more than one. Okay,